Okay, today we're going to wrap up our radical operations. Today we're going to talk about how to add and subtract radicals. Now the good news about today is this is very similar to something that we already know how to do. If we want to add or subtract radicals, it's actually going to be very similar to simplifying algebraic expressions using addition and subtraction. So let's write down some steps here. The first thing we're going to do if we want to add or subtract radicals is we've got to simplify all of the radicals. So if I have a perfect square underneath the radical sign, I've got to cake that number. If I have a fraction underneath the radical sign, I would need to get rid of that. And if I have a radical in the denominator of a fraction, I would need to get rid of that as well. Now, once all radicals are simplified, we are going to look at my set of radicals and we're going to add or subtract the coefficients. Now I put coefficients in quotes because it's not really coefficients, but you'll see what I'm talking about here in just a minute. It looks kind of like a coefficient. We're going to add or subtract the coefficients of like radicals. Once again, I'm going to put that like in quotes because it is kind of like radicals, but we usually associate that when we're talking about terms, algebraic terms. So let's make some sense of this. Let's get into some examples. For the first one, if I have 15 square roots of 2 minus 8 square roots of 2. If I look at my radicals, I have square root of 2, I have a square root of 2. If my radicals match, all I'm going to do is I'm now going to treat any radicals that are the same as if they were the same term. So if this was a 15x, and an 8x, think about how you would combine those together. You would take 15 minus 8, and you would get 7x, but instead of x, we have a square root of 2. So 7 square roots of 2. So notice how it really is very, very similar to simplifying expressions by addition and subtraction. Okay, what if we have 8 square roots of 3 plus 6 square roots of 3? Okay, the square root of 3, the square root of 3, those are in simplest form. Notice that they match, the square root of 3 and the square root of 3, so I can add those together. So if I take 8 square roots of 3, or think about it as 8x plus 6x, that would give me 14x. But instead of x, we use square roots of 3. Okay, let's try one that needs a little bit of work. Number 3, negative 2 square roots of 24 minus 3 square roots of 6. Now, if I look at these ones, notice that the square root of 24, the square root of 6, those don't match. So as they are, I cannot combine those together. But if we follow that first step and make sure our radicals are simplified, something might change. So if I take that 24, I divide out of 2, I get 12. Divide out of 2, I get 6. Divide out of 2, I get 3. Divide out of 3, I get 1. So I have a pair of 2's, but I had that negative 2 in the beginning. Negative 2 times 2 gives me negative 4. I'm left with a 2 times 3, which is 6. Okay, and if I try to cake 6, you divide out of 2, you get 3. Divide out of 3, you get 1. There would be no pairs, so that's in simplest form. So that just stays negative 3 square roots of 6. So notice now my radicals match. So I can combine those together. So negative square roots of 6 minus 3 square roots of 6 gives me negative 7 square roots of 6. Let's try another one like that. Number 4. 5 square roots of 80 minus 12 square roots of 5. So once again, notice that my radicals don't match, but if I simplify those, take that 80, divide out of 2, you get 40, divide out of 2, you get 20, divide out of 2, you get 10, divide another 2, you get 5, divide out of 5, you get 1. So I have a pair of 2's here, a pair of 2's here, so I have 2 times 2, I had a 5 in the beginning, 2 times 2 times 5, gives me 20. I'm left with the square root of 5. That second radical is already in simplest form, so it stays the same. Notice, square root of 5, square root of 5. So if I add or subtract the coefficients, 20 square roots of 5 minus 12 square roots of 5 gives me 8 square roots of 5. Okay, number 5. If I have 3 square roots of 32 minus 4 square roots of 63. Okay, my radicals don't match, so let's look and see if we can simplify those. If I take the 32, divide out of 2, Take the 16, divide out of 2, I get 8, divide out of 2, I get 4, divide out of 2, I get 2, divide out of 2, I get 1. Lots of pairs here. Okay, I have a pair of 2's and a pair of 2's. 2 times the 3 in the beginning gives me 12. I'm left with the square root of 2. And then let's take the 63. Divide out of 3, I get 21. Divide out of 3, I get 7. Divide out of 7, I get 1. I have a pair of 3's times the 4 out front, I get minus 12, and I'm left with the square root of 7. Now this time notice I have the square root of 2, and I have the square root of 7. Those do not match, so I cannot combine those together. So this would be your answer. That would be how you would simplify that. All you can do is simplify the radicals. If you can't combine them together, you can't combine them together. You would just leave your answer like that. Okay, number 6. I want you guys to try this one on your own. I'll be working it out silently in the video so you can check as you go. 3 square roots of 24 plus 4 square roots of 150. Okay, try that one on your own. Okay, once you simplify those radicals, should have both of them are the square roots of 6, so you can combine them together. Get 6 square roots of 6 plus 20 square roots of 6 gives you 26 square roots of 6. Okay, I have 2 more for you. Number 7. Okay, let's try negative 3 square roots of 72 plus 6 square roots of 52 minus 7 square roots of 128. Nothing changes here. I just have to do a little bit more work because I have 3 radicals that I have to simplify, because notice none of them match right as they are. So if I take that 72 first, divide out of 2, I get 36. Divide out of 2, I get 18. Divide out of 2, I get 9. Divide out of 3, I get 3. Divide out of 3, I get 1. Pair of 2's, a pair of 3's, which gives me a 6, times that negative 3 out front gives me negative 18 square roots of 2. Okay, and then take the 52. Divide out of 2, you get 26. Divide out of 2, you get 13. Divide out of 13, you get 1. So I have a pair of 2's times the 6 out front gives me plus 12 square roots of 13. And then lastly, let's take that 128. Divide out of 2, you get 64. Divide out of 2, you get 32. Divide out of 2, you get 16. Divide out of 2, you get 8. Divide out of 2, you get 4. Divide out of 2, you get 2. Divide out of 2, you get 1. Lots of 2's there. Okay, so I have a pair of 2's, a pair of 2's, a pair of 2's. So 2 times 2 times 2 gives me 8. 8 times this 7 gives me 56, and I'm left with the square root of 2. So we're looking for the terms that have like radicals. So notice I have the square root of 2, and I have the square root of 2. So those coefficients, those radicals, I can combine together. This one has to stay by itself. That 12 square roots of 13 can't combine with anything. It's going to stay the same. So negative 18 square roots of 2 minus 56 square roots of 2 gives me negative 74 square roots of 2. And you could switch those around. If you put the negative 74 square roots of 2 out front, that would be fine. But just like whenever we're simplifying algebraic expressions, you just have to make sure you take the signs with them. Okay, this last one is going to be kind of like number 7. I want you guys to try it on your own. I'll be working it out silently in the video. So number 8, 4 square roots of 112 plus 5 square roots of 56 minus 9 square roots of 126. Okay, so try that one on your own. Okay. When you simplify those, we should get 16 square roots of 7 plus 10 square roots of 14 minus 27 square roots of 14. The square roots of 14 you can combine together. That 16 square roots of 7 is just going to stay the same. Should get 16 square roots of 7 minus 17 square roots of 14.